I've got a problem here where we want to find the magnitude and the direction of this vector. So let's use vector components to solve this problem. First of all, let's look at what we're given. So we're given that the angle between the positive x value, or the positive x-axis, and the vector is 120 degrees. So this is given. And we're given 2 points, the start point of the vector and the ending point of the vector. So start 0, 0, end 0, or -2, 5. So from these starting and ending values, we can essentially just write out the components. So px is just the length of the vector along the x value, or the x-axis, and then the y component, and this should go here. The y is the value of the length along the y-axis. So px, we can say, is 0 because we started 0, and then we add the x component of the other one, the endpoint, -2. So the x component of this vector is -2. Y is 0, because we have 0 at the start, plus 5. So py is 5. Now, notice we have both components, and we're looking for the magnitude of this vector. So knowing both components, how do we solve for the magnitude? Well, the easiest way would be to use Pythagorean's theorem, like so. So we get -2 squared plus 5 squared, which is 29, square root of 29, or in decimal form, it's about 5.39. And so we have our magnitude now. So that's half of what a vector is, but now we want to find its direction. So one thing you can do, and we actually have a direction given to us in the form of an angle. So in a sense, you could just give your answer like this. You've got a vector that's a magnitude of 5.39 at 120 degrees. So that is a valid answer, because by convention, the positive x-axis is 0, so this is convention. This is 0 degrees, this is 90 degrees, 180 degrees, and 270 degrees. So this is by convention. So if you say 120 degrees, you know, everyone knows it's in this quadrant here. But there are a lot of times where you want to express it in the form of like a direction, like on a compass, where you have north, south, east, and west. So there's a lot of times questions will want you to put it in this form. And in order to do that, we need to look at this angle. We'll call it phi. So this angle, if we express it in this angle, then we can more easily find express it in terms of like a compass direction. So we can find this angle based on what we know about this angle here. And how we relate the two is we say that phi is this angle minus 90 degrees. because you got this whole chunk you want to get rid of, this whole quadrant, and you only want to consider the right triangle. So this whole 90 degrees we don't care about. So that's 120 degrees minus 90, and phi is equal to 30 degrees. Okay, so if we think about this compass here, and we have our vector basically here with this angle being 30 degrees. What we can say then, in terms of direction, is that this is 30 degrees west of north. So it's west of north because we have this angle with respect to the north axis. If you wanted to consider this angle, which would be 60 degrees, you could also say 60 degrees north of west because it's north with respect to the west axis. Okay, and I'm going to stick with the 30 because that's the angle we defined here, although either, it doesn't really matter. Now I'm going to re-express our number, our vector, as 5.39 at 30 degrees west of north. And that's the final answer. You don't have to use the @ sign if you don't want. You can just put a comma or whatever. As long as you have both the magnitude and the direction, then you have a complete vector answer. Note one thing, it's not enough to just say p equals 5.39 30 degrees northwest, because you don't know whether it's north of west or west of north. So you have to have something of something in there in order for it to make sense. So that's just one example. I'll do more in the following videos, but hope that was useful.